Now let's have the discussion on one of the important topic from winding connections, that is star zigzag star connection. And here the assumption is primary is HV and secondary is LV, which means that on primary side the winding is star connected, which is HV winding, and on secondary side the winding is zigzag star connected and which is LV winding. If suppose these three are the HV windings on primary side, and let this be the dotted terminals, and now let's give the notations for these coil ends, as the dot ends are given capital A2, capital B2 and capital C2 notations, and the non-dot ends capital A1, capital B1 and capital C1. Here the notations are in capital letter because this winding represents HV winding, and as this HV winding is star connected, let's have the star connection. And star connection can be obtained either by joining the dot ends and taking the connection from non-dot ends, or by joining the non-dot ends and taking the connection from dot ends. Here let us suppose that non-dot ends are joined together and taking the connection from dot ends. This is the star connection on primary side. Now let's have the zigzag star connection on secondary side, and it is known that each phase of zigzag star connection is divided into two equal halves. Let these three be the one half of the LV winding, and let these three be the other half of the LV winding, and let these be the dot ends of the windings. And now let's give the notations for these windings, and dot ends are given small a2, small b2 and small c2 notations. Here the notations are in small case because this represents the LV winding, and the non-dot end terminals a1, small b1, small c1. And coming to this half section, dot end terminals are small a4, small b4, small c4, and non-dot ends small a3, small b3 and small c3. It is studied that zigzag star connection is also called as interconnected star because one half of the LV winding is star connected, and that star connection can be obtained either by joining the dot ends together or by joining the non-dot ends together. Here in this case, let's join the dot ends together. So now let's join the dot end terminals together and give it to the ground, and let this terminal be N. And now this star connected half section LV winding is to be connected to the other half section of LV winding, such that the triple harmonics will get reduced to 0. So now here our task is to join this phase winding with the other phase winding, such that these two must be connected in phase opposition. And to have phase opposition connection, we need to join either two dot end terminals or we need to join either two non-dot end terminals. And here we are joining the two non-dot ends together to have phase opposition connection. Okay, so A1 here is the non-dot end of A phase, which is connected to the non-dot end of B phase. So with this connection we can say that this winding and this winding are connected in phase opposition because we join the non-dot end terminal of this winding with the non-dot end terminal of this winding. Similarly, let's join the non-dot end B1 with the non-dot end C3, and similarly non-dot end C1 is connected to non-dot end A3. So this is the zigzag star connection. Therefore these two together will represent the one of the possible way of zigzag star connection. We can have zigzag star connection in 4 possible ways, means we can obtain zigzag star connection in 4 ways, and in this video we are going to see only the 2 main possible connections of star zigzag star connection, and this is the one of the way of obtaining the zigzag star connection. Now let's see the phasor diagram for this type of zigzag star connection. First, coming to the primary side, as this is the star connected, let's consider the VA phasor like this, and now let's decide the terminals of this VA phasor. And by observing this winding connection, okay, connection is took from dot end terminal, that is A2. Therefore arrow will point towards the connection we took from. So arrow will point towards A2 and the other end will be A1. Now we must draw the VB phasor, and it is known that in three-phase ABC phase sequence system, VA will be at an angle 0 degrees and VB will be at an angle minus 120 degrees from VA, and VC will be at an angle minus 240 degrees from VA. So VB phasor will be at an angle minus 120 degrees from VA. So as this is the VA phasor in this direction, so in clockwise direction at an angle minus 120 degrees there will be VB phasor. And observing winding connection that to A1 there is B1 connection, means A1 must have B1, and as connection is took from dot and terminal, that is B2, arrow will point towards B2. Therefore the VB phasor will be like this. Now we must draw the VC phasor. So VC phasor will be at an angle minus 240 degrees from VA. Therefore from VA at an angle minus 240 degrees there will be VC phasor. And observe that in winding connection to A1 and B1 there is C1. Therefore here there must be C1 to A1 and B1. And observe that in winding connection is took from dot and terminal, that is C2. Therefore arrow will point towards C2. Therefore the VC phasor will be like this, and this is C2 and this is VC phasor. And here in this star connection to A1, B1 and C1 connection, the common notation is given as capital N, which represents the neutral point. So this is the phasor diagram for this star connection. Now let's have the phasor diagram for this zigzag star connection, in which first we must draw the phasor diagram for the internal star connection, and it is studied that secondary side phasors are drawn parallel to primary side phasors. And to avoid confusion, let's indicate the voltages in these windings. Okay, let this be VA X1, VB Y1, VC Z1, and the voltages in this half section be VA X2, VB Y2 and VC Z2. Now first let's draw the secondary side VA X1 phasor. Therefore let's draw the secondary side VA X1 phasor parallel to primary side VA phasor like this. And now we need to decide the direction of secondary side VA X1 phasor, and the direction depends on the connection we took on primary side and secondary side. And by observing on primary side, connections are took from dot and terminals, and coming to the secondary side, connections are took from non-dot and terminals. Therefore the direction of secondary side VA X1 phasor will be opposite to primary side VA phasor. So as the primary side VA phasor direction is like this, therefore the secondary side VA X1 phasor direction will be like this. And now we need to decide the terminals of this secondary side VA X1 phasor, and the terminals here are A1 and A2, and the connection is took from non-dot end, and as arrow point towards the connection we took from, therefore arrow terminal will be A1 and the other terminal will be A2. Now we must draw the secondary side VB/Y1 phasor. So let's draw the secondary side VB/Y1 phasor parallel to primary side VB phasor like this. And now we need to decide the direction of secondary side VB/Y1 phasor, and which depends on the connections we took on primary side and secondary side. So here on primary side connections took from dot end, and here on secondary side connections took from non-dot end, means the direction of secondary side VB/Y1 phasor is opposite to the direction of primary side VB phasor. Therefore the direction will be like this. And now we need to decide the terminals of secondary side VB/Y1 phasor, and here the terminals are B1 and B2, and as the connection is took from non-dot end, that is B1, therefore arrow will point towards the connection we took from, that is B1, and other end will be B2. Now coming to this winding connection, A2 has B2 connection, means here in phasor diagram to A2 there must be B2. Therefore draw this VB/Y1 phasor such that A2 will have B2 connection. So like this. Now we need to draw the secondary side VC/Z1 phasor. So let's draw the secondary side VC/Z1 phasor parallel to primary side VC phasor somewhere here like this. This is VC/Z1, And now we need to decide the direction of secondary side VCZ1 phasor. So direction depends on the connection we took on primary side and secondary side. So here on primary side connection is took from dot end, and on secondary side connection is took from non-dot end. Means the direction of secondary side VCZ1 phasor is opposite to the direction of primary side VC phasor. Therefore the direction will be like this. And now we need to decide the terminals of secondary side VCZ1 phasor. Here the terminals are C1 and C2, and as the connection is took from C1, therefore arrow will point towards C1 and other end will be C2. And observe in winding connection that to A2 and B2 there is C2 connection, means here there will be C2. So therefore draw this VCZ1 phasor such that A2 and B2 will have C2. Therefore like this end is C1. And let's give the common notation here, small n. And this is the phasor diagram for this internal star connection. Now we need to draw the phasor diagram for this other half section of LV winding. And observe that here to A1 there is B3 connection. Means we must draw the VB/Y2 phasor from A1 because A1 is having B3 connection. Therefore let's draw the secondary side VB/Y2 phasor. Therefore drawing secondary side VB/Y2 phasor parallel to primary side VB phasor somewhere here like this. And now we need to decide the direction of secondary side VB/Y2 phasor. So observe that on primary side connection is took from dot end, and on secondary side connection is took from dot end. Therefore the secondary side VB/Y2 phasor direction is same to that of primary side VB phasor. So therefore like this. This is VB/Y2. And now we need to decide the terminals of this VB/Y2 phasor. Here the terminals are B3 and B4, and as the connection is took from dot end B4, therefore arrow will point towards B4 and other end will be B3. Now draw this secondary side VB/Y2 phasor such that A1 will have B3 connection. Therefore draw like this, and this end will be B4. This is VB/Y2 phasor. Therefore now the resultant voltage is VB4N. And now coming to this non-dot end terminal B1, it is having connection with C3. Therefore to B1 there must be C3. Therefore we must draw the secondary side VCZ2 phasor from B1. Therefore let's draw the secondary side VCZ2 phasor parallel to primary side VC phasor like this. And now we need to decide the direction of this secondary side VCZ2 phasor. And here on primary side connection is took from dot end, and here on secondary side connection is took from dot end. Therefore the direction of secondary side VCZ2 phasor is same to that of primary side VC phasor. And now we need to decide the terminals of secondary side VCZ2 phasor. And here the terminals are C3 and C4, and the connection is took from dot end C4. Therefore as arrow points towards the connection we took from, so this end will be C4 and this end will be C3. Now draw this secondary side VCZ2 phasor such that B1 will have C3 connection. Therefore like this. This end is C4. And now the resultant voltage is VC4N. Now observe in winding connection that to C1 there is A3 connection. Means in phasor diagram to C1 there must be A3. Therefore now we must draw the secondary side VAX2 phasor from C1. So let's draw the secondary side VAX2 phasor parallel to primary side VA phasor somewhere here like this. This is VAX2 phasor. And now we need to decide the direction of secondary side VX2 phasor. And observe that in winding connection is took from dot end, and here on secondary side connection is took from dot end. Therefore the direction of secondary side VX2 phasor is same to that of the direction of primary side VA phasor. So like this. And now we need to decide the terminals of this secondary side VX2 phasor. And observe that, and the terminals here are A3 and A4, and the connection is took from dot end terminal, that is A4, as the arrow in phasor diagram points towards the connection we took from. Therefore this end is A4 and other end is A3. Now draw the secondary side VX2 phasor such that C1 will have A3 connection. Therefore like this. This end is A4. This is VAX2 phasor. Therefore now the resultant voltage is V, A4, N. This is the phasor diagram for this zigzag star connection, which consists of the phase voltages V, A4N, V, B4N and V, C4N. These three are the phase voltages of this zigzag star connection, and each phase voltage of zigzag star connection is the vector sum of the voltages induced in the windings of different phases. Okay, here VA4N consists of A phase voltage and C phase voltage, and these two windings are offset by 120 degrees and which are connected in phase opposition in order to reduce the triplet harmonics to 0. Now let's identify the vector group symbol for this type of star zigzag star connection, and it is known that the first character in vector group symbol is in capital letter, and that will indicate the HV winding connection, and here the HV winding connection is star, so to represent that here is taken in capital Y. And now the second character in vector group symbol is in smaller case, and that will indicate the LV winding connection, and here the LV winding connection is zigzag star, so to represent that here in vector group symbol it is taken in small z. And now we need to decide the numerical of vector group symbol, which will indicate the LV side phase unit voltage displacement with respect to HV side phase unit voltage, and here we are comparing the A phase. So here on LV side the phase unit voltage is VA4N, and on HV side the phase unit voltage is A to N. In vector groups, HV side phase unit voltage is always taken as reference, and it is indicated by minutes needle in clock. Therefore, if you consider this as clock, then as the HV side phase unit voltage is taken as reference and it is represented with minutes needle, therefore in clock the minutes needle is always shown pointing towards 12, and in vector groups the LV side phase unit voltage is represented with hours needle in clock. So to find the numerical in vector group symbol, we need to superimpose this phasor diagram on this phasor diagram and observe the phase unit voltage of HV winding and LV winding. So if you superimpose LV winding phasor diagram on HV winding phasor diagram, then the HV side phase unit voltage will look like this, and LV side phase unit voltage will look like this. This is A4 and this is N. It is taken as short because LV side phase unit voltage is represented with hours needle in clock. Okay, now place this diagram in clock such that HV side phase unit voltage will point towards 12. So upon placing, then the hours needle will be shown pointing towards 1, and these corresponding positions in clock represents 1 o'clock. Therefore, the numerical in vector group symbol is 1, which will indicate the LV side phase unit voltage displacement with respect to HV side phase unit voltage, and that is given by the angle between minutes needle and hours needle in clock. So if you measure in clockwise direction, then the angle between minutes needle and hours needle is minus 30 degrees. Therefore, with this type of zigzag star connection, we got a phase displacement of 30 degrees lag. Now let's see the second possible connection of star zigzag connection. In this connection, we join the dot and terminals, and now in second possible connection, we will join the non-dot and terminals A1, B1 and C1. Now let's see that. Therefore, now let's join the non-dot and terminals small a1, small b1 and small c1 together and give it to the ground, and let this terminal be small n. So this is the star connection for this half section of LV winding, and now we need to connect this half section of LV winding with this half section of LV winding such that the triplet harmonics in each phase winding of zigzag star connection must be reduced to 0. For that, we need to connect this A phase winding with this B phase winding such that these two windings must be in phase opposition. To have the windings in phase opposition, we need to connect either the non-dot and terminals together or dot and terminals together. Okay, here we need to connect the dot and terminal of this A phase coil with the dot and terminal of this B phase coil. Therefore, let's join the dot and terminal A2 with dot and terminal B4, and similarly let's join the dot and terminal B2 with dot and terminal C4. and similarly dot end terminal C2 with dot end terminal A4. Therefore, this is the second possible connection of star zigzag star connection. In this, on primary side, we didn't change any connection. Therefore, we left the phasor diagram as it is. Now, let's draw the phasor diagram for this zigzag star connection. So, first we must draw the phasor diagram for this internal star connection. So, let's draw the secondary side VAX1 phasor parallel to primary side VA phasor like this. And now we need to decide the direction of secondary side VAX1 phasor. Okay, and that direction depends on the connection we took on primary side and secondary side. On primary side consists from dot end, and on secondary side consists from dot end. Therefore, the direction of secondary side VAX1 is same to that of primary side VA phasor. So like this. And now we need to decide the terminals of secondary side VAX1 phasor. Okay, here the terminals are A1 and A2, and as they consist from dot end terminal, that is A2, therefore arrow will point towards the connection we took from. Therefore, this end is A2 and other end will be A1. Now we must draw the secondary side VBY1 phasor. Therefore, let's draw the secondary side VBY1 phasor parallel to primary side VB phasor somewhere here like this. And now we need to decide the direction of secondary side VB/1 phasor. So observing primary side winding connection that consists from dot end, and here on secondary side consists from dot end. Therefore, the direction of secondary side VB/1 phasor is same to that of the direction of VB phasor. So like this. Now we need to decide the terminals of this VB/1 phasor. So terminals are B1 and B2, and as they consist from dot end terminal, that is B2, therefore arrow will point towards B2 and other end will be B1. And now observing winding connection that to A1 there is B1 connection, means here to A1 there must be B1. So draw this phasor diagram such that A1 will have B1. Therefore, like this. This is B2. Now let's draw the secondary side VCZ1 phasor. So let's draw the secondary side VCZ1 phasor parallel to primary side VC phasor somewhere here like this. This is VCZ1. And now we need to decide the direction of secondary side VCZ1 phasor. On primary side consists from dot end, and on secondary side consists from dot end. Therefore, direction of secondary side VCZ1 phasor is same to that of primary side VC phasor. So like this. Now we need to decide the terminals of this secondary side VCZ1 phasor. So terminals are C1 and C2, and they consist from dot end terminal, that is C2. Therefore, arrow end will be C2 and other end will be C1. Now observing winding connection that to A1 and B1 there is C1 connection, means here there will be C1. So draw this VCZ1 phasor such that A1 and B1 will have C1. Therefore, like this. And now let's give the common notation for this A1, B1 and C1 terminal, that is small n. So this is the phasor diagram for this internal star connection. Now let's draw the phasor diagram for this other half section of LV winding. Observe that here to dot end terminal A2 there is B4 connection, means to A2 there must be B4, means we must draw VBY2 phasor from A2. Therefore, let's draw the secondary side VBY2 phasor somewhere here parallel to primary side VB phasor. And now we need to decide the direction of secondary side VBY2 phasor. Observe that on primary side consists from dot end, and on secondary side consists from non-dot end, means the direction of secondary side VB/2 phasor is opposite to the direction of primary side VB phasor. So like this. Now we need to decide the terminals of secondary side VB/2 phasor. So terminals are here B3 and B4, and they consist from non-dot end, that is B3. Therefore, arrow will point towards B3 and other end will be B4. Therefore, draw this VB/2 phasor such that A2 will have B4 terminal, means like this. This is B3. This one is B4. Therefore, now the resultant voltage is VB3N. And now coming to this winding connection, to dot end B2 there is C4 connection, means in phasor diagram to B2 there must be C4, means we must draw VCZ2 phasor from B2. Therefore, let's draw secondary side VCZ to phasor parallel to primary side VC phasor somewhere here like this. And now let's decide the direction of secondary side VCZ to phasor, and observe that in winding connection on primary side connection is took from dot end, and here on secondary side connection is took from non-dot end, means the direction of secondary side VCZ to phasor is opposite to the direction of primary side VC phasor, like this. Now we need to decide the terminals of secondary side VCZ to phasor. So terminals are C3 and C4, and as the connection is took from non-dot end, that is C3, arrow end will be C3 and other end will be C4. Therefore, now draw this VCZ to phasor such that B2 end will have C4. Therefore, like this. This end is C3. Therefore, the resultant voltage is VC3N. Now observe that in winding connection, dot end C2 is having connection with A4, means to C2 there must be A4, means we must draw secondary side VAX2 phasor from C2. Therefore, let's draw secondary side VAX2 phasor somewhere here parallel to primary side VA phasor. Okay, and now we need to decide the direction of secondary side VAX2 phasor. Okay, observe that on primary side consists from dot end and on secondary side consists from non-dot end, means the direction of secondary side VAX2 phasor is opposite to primary side VA phasor. And now let's decide the terminals of secondary side VAX2 phasor. Terminals are A3 and A4 and the connection is from non-dot end. Therefore, arrow end will be A3 and other end will be A4. Now draw this secondary side VAX2 phasor such that C2 will have A4 connection, means like this. This end is A3. Therefore, now the resultant voltage is VA3N. So this is the phasor diagram for this zigzag star connection, which is having the phase voltage of VA3N, VB3N and VC3N, and each phase voltage in zigzag star connection is the vector sum of the two voltages induced in the two windings of different phases and which are connected in phase opposition and which are offset by 120 degrees. So if you consider VA3N phase voltage, okay, this is the vector sum of the voltage induced in C1 and C2 and the voltage induced in A3 and A4, and these two windings are offset by 120 degrees, and these two are connected in phase opposition because dot end of A phase and dot end of C phase are joined here in A3N. So this is the second possible connection of star zigzag star connection. Now let's identify the vector group symbol for this type of zigzag star connection. Okay, and it is known that the first character in vector group symbol is in capital letter and that will indicate the HV side connection, and here HV side connection is star. Therefore, the first character in vector group symbol is capital Y, and the second character in vector group symbol is in smaller case, and that will indicate the LV connection, and here the LV connection is zigzag star. So here the second character in vector group symbol is small z. And now we need to decide the numerical in vector group symbol, which will indicate the LV side phase neutral voltage displacement with respect to HV side phase neutral voltage. And here we are comparing the A phase. So the LV side phase neutral voltage is VA3N and HV side phase neutral voltage is A2N. In vector groups, the HV side phase neutral voltage is always taken as reference and is indicated with minutes needle in clock. Therefore, if you consider this as clock, as HV side phase neutral voltage is represented with minutes needle and is taken as reference, so minutes needle in clock will always be shown pointing towards clock, and the LV side phase neutral voltage is represented with hours needle in clock. And to know the numerical in vector group symbol, let's superimpose this phasor diagram on this phasor diagram and observe the phase neutral voltage of HV side phase neutral voltage and LV side phase neutral voltage. So upon superimposing, the HV side phase neutral voltage will look like this and LV side phase neutral voltage will look like this. This is A3 and this is small n. It is taken in short because the LV side phase neutral voltage is represented with hours needle in clock. Now place this diagram in clock such that HV side phase neutral voltage points towards 12, then hours needle will be shown pointing towards 7, and this corresponding position represents the 7 o'clock, means the numerical in vector group symbol is 7 for this type of zigzag star connection, which will indicate the LV side phase neutral voltage displacement with respect to HV side, and that is given by the angle between minute needle and hours needle. If you measure in anti-clockwise direction, then the angle is plus 150 degrees, and if you measure in clockwise direction, it will be minus 210 degrees. So this is the second possible connection of star zigzag star connection, from which we got a phase displacement of 150 degrees. Star zigzag star connection has 4 possible connections, and of that we discussed the 2 main possible connections. So this is about star zigzag star connection. Now let's know the phase voltage ratio and line voltage ratio of star zigzag star connection. Let small v1 be the primary side phase voltage and small v2 be secondary side phase voltage. Then transformation ratio constant K is equal to small v2 by small v1, which implies small v2, that is secondary side phase voltage, is K into v1. And now coming to this zigzag star connection, in which each phase winding is divided into 2 equal halves, means the voltages induced in 2 windings of A phase can be taken as K v1 by 2 and here K v1 by 2. Now let's find out the VA3N voltage, which is the phase voltage of zigzag star connection, and which is given as the vector sum of the 2 voltages induced in the windings of different phases. Okay, so as we are considering the VA3N, here the voltage induced in A phase is VAX2 and the voltage induced in C phase is VCZ1. And for simplification, let us assume that voltages in each winding are same, means that is equal to K into V1 by 2 plus K into V1 by 2. These two are vector sums. And now by applying the triangle rule of vectors, we get VA3N is equal to root over K into V1 by 2 whole square plus K into V1 by 2 whole square plus 2 into K into V1 by 2 K into V1 by 2 into cos theta, where here theta is 60 degrees. Therefore, let's replace cos theta with cos 60 degrees, which is equal to 1 by 2, and that equals to root over 3 into K into V1 by 2 whole square, that is equal to root 3 times K into V1 by 2. Therefore, now if you rearrange this equation, VA3N by small v1 is equal to root 3 by 2 into K, and if you observe that VA3N is the secondary side phase voltage and small v1 is the primary side phase voltage, means this is the phase voltage ratio of star zigzag star connection. Now let's find out the line voltage ratio of star zigzag star connection. For that, let capital V1 be primary side line voltage and capital V2 be secondary side line voltage. Now observe that in LV side the connection represents star, means the relation between phase voltage and line voltage on LV side is line voltage is equal to root 3 times phase voltage, means line voltage on secondary side V2 is equal to root 3 times the phase voltage on secondary side. So this is the relation for the LV side zigzag star connection between line voltage and phase voltage. And now observe in primary side, this is star connected, and the relation between phase voltage and line voltage here is line voltage is equal to root 3 times phase voltage, means the primary side line voltage V1 is equal to root 3 times the primary side phase voltage. And on secondary side, which is a zigzag star connection, and the phase voltage V2 is VA3N. Therefore, replace this secondary side phase voltage VA3N with its corresponding line voltage, and similarly replace the primary side phase voltage with its corresponding line voltage. Implies capital V2 by root 3 by capital V1 by root 3, which is equal to root 3 by 2 into K. Here 1 by root 3 and 1 by root 3 gets cancelled, which implies capital V2 by capital V1 is equal to root 3 by 2 into K. So this is the line voltage ratio for star zigzag star connection, and upon simplification V2 by V1 is equal to K root 3 by 2 is 1.732 by 2, which will give you 0.577, and here K, which implies for K is equal to 1, V2 is equal to 0.577 into V1 for K is equal to 1. From this relation we can say that secondary side line voltage is 50% of primary side line voltage, which means star zigzag star connection is used for step down applications. So this is about star zigzag star connection.